did we set out to solve? When we first started thinking about this, what did we want to solve or think could be solved with algorithms? And it all starts with this this phenomenon. It's a psychological phenomenon, and we have a review article there. I'll share the slides, and you can check out some of them. I'm sure there's more since I found that. That's about a year old now. And the phenomenon is, when you are emotionally engaged, increased emotional content actually depresses cognitive function. So if an article figures out a way to make you angry, to give you a sense of urgency, to make you afraid, then your brain stops working as well as it usually does. You're actually less able to think about the facts when somebody puts you in an emotional state. And this is, I'm not talking about you, nothing personal. This is a human thing, right? This is something that I've told this joke so many times that that I convinced IBM to write a cartoon about it. So get ready, this is a joke. So you might think, this is a horrible defect in humanity, right? When we care about something, we can't think about it well. Maybe if you ever get in a fight with your significant other, you've experienced this. I've got a great marriage. That wasn't facetious. Walter will tell you. You can imagine in the olden days, in caveman days, two cavemen are walking. They're trying to find a new shelter, and they see a shadow like a bear in the back of the cave. You're not sure, well, is that a bear? Is that not a bear? I don't know. And the first caveman, who is the more scientific, I guess, of the Neolithic, has the most scientific Neolithic brain, says, I'm gonna really think about this. I'm gonna scrutinize all of the evidence. I'm going to interrogate my hypotheses, and only when I'm absolutely sure that am I going to conclude that there's a bear in the back of the cave. And the other one gets the hell out of there. And the moral of the story is, which one do you think survived, on average, to become your ancestor? Right? It is almost an adaptation, at least in the environment in which this is not a scientifically rigorous argument, but it actually at least makes room for the idea that there's reason why historically we've developed our way of processing knowledge and not processing knowledge, and just not overthinking things in certain contexts. And this is what gets taken advantage of in fake news. At least that's the hypothesis. That was the driving underlying backdrop of our project here, right? And so instead of thinking, well, okay, that's the philosophical part of the talk. Now let's talk about deep learning. So let's just I want to go through this. 9%. Okay. If we do one hot encoding, so we give every dimension every word its own dimension. Every word is going to be equally far away from every other word. So there's no semantics captured in the way we're representing our terms mathematically. And so in order to solve that problem, a very simple trick will have it. It's sort of inspired by Wittgenstein, right? Wittgenstein says the meaning of the word is the context of the words around it. Well, this is the 21st century answer to that, verification of that claim, which is that if you have a word and you represent it in this mathematical space, in order to control for recursive dimensionality, control for the way too many dimensions, and so data sparsity, you compress it down to, usually it's about 100, 200, 300 is kind of the sweet spot, dimensions for text at least. And then you can, you don't have to worry about this data sparsity issue. And then you're having the algorithm solve this very simple task like guess the words around it, or guess the missing word, guess the next word, the cat sat, fill in the blank. And by doing that, and by using backprop in order to learn those embedding, those values in those 300 dimensions for every single word, what ends up happening is you capture that, you solve for that second problem too. So not only have you compressed it down to a dimensionality of your choosing, you have a, let's say 1,000,000 by 300 dimensional matrix, so about 300 million parameters. You're also now, because you've compressed it into this lower rank vector space, you capture the meaning of the word. So similar words and synonyms will end up getting mapped to similar places. And if you think about that, I woke up this morning, I brushed my teeth with my toothbrush, and then I put on my slacks. I woke up this morning, I brushed my teeth with my toothbrush, and I put on my pants. I woke up this morning, I brushed my teeth with my toothbrush, and I put on my power drill, right? You're going to see some of these more similarly in the same context than others. And so it makes sense that similar words are going to end up getting parameterized, represented in this vector space more closely when they're found around the same, gee whiz. We need a bigger room. So another thing, which is what this GIF, so this GIF is done by Chris Moody originally from Stitch Fix. This is the famous example. You take the king vector and you subtract the masculinity and you add femininity, so you have these vector representations of every word, so you can do vector arithmetic with all of them. Then you end up with the queen vector. And that's exactly what ends up happening. So the early versions of or benchmarks were actually done on trying to solve analogies, solve these simple analogies like England is to London as Paris is to France. So that was 2013. Since then we've had a lot of different advances and tweaks on this. So Glove came out. That Glove is kind of like the Stanford version of it. If you come from Stanford, you're probably using Glove. FastTech came out a couple years ago, and that's a little bit different, but it's also essentially the same strategy. Okay, and so now let's think. Okay, well, we want to deal with text. We want to deal with documents. So around this. And then you have a vector that's sort of pointing in the direction, sort of like a random walk, but slowly you're going to drift in the direction. And since there's semantics now commutative, right? So if you're taking the average or you're summing and then normalizing, the order of the words is not going to get captured. So these two sentences, Jill broke her crown but did not fall down, Jill fell down but did not break her crown, are telling you opposite facts, but are actually going to be encoded the same way because it's just all I've done is permuted position of the words. You can't hear me? No. So, is this better? Okay. So another one, and this came out shortly after the original Miklos paper, is paragraph to vec. So this is where you can actually learn a context vector, this paragraph ID vector, and the idea here is that there is a what if there's a missing context vector that actually, if I had this information, I would do better in solving this simple problem of guess the next word. And the underlying thought here is that this context vector kind of has some semantic significance in itself. It's adding that extra information that helps you to solve these fill-in-the-blank problems. So first you learn the individual words, then you freeze those, and now you're backpropping through to learn this paragraph ID parameterization. It's going to be embedded in the same space, and that's going to take a little bit, it's going to help with things like order permutation. But that is like old news. That's I used to say word2vec is new, but it's not that new anymore. It's like 5 years old, right? So now, lately, it's not like recurrent neural nets are that new too, but what we've been able to do with them in the last couple of years is very new. And we've really, run with this idea that we can now that we can semantically encode individual words, we can do so much with those individual words, right? So a recurrent neural net, who knows what a recurrent neural net is? Everyone. Okay, I'm not going to talk about it then. Who knows an LSTM? Who can like rattle off these equations by hand, right? So an LSTM, and then if you add peepholes, it looks like that. An LSTM is a recurrent neural network. It's got this cell state. And this cell state, in addition to like a recurrent neural net, will pass its output, its hidden states. It will feed it up, and then also with the xt+1, it will pass that to the next recurrent union. So you not only get the next iteration in the time series, whatever that time series is. So it could be telemetry, it could be stock market, it could be words in order. You also keep track of the cell state, which is really doing an important thing in this, that's very effective, especially when we're talking about grammar and looking at text, which is keeping track of things like what should I pay attention to. And if you kind of squint your eyes, you can believe me that when I talk in a very long run-on sentence with a lot of relative clauses, and you're not sure when it ends, and you have to remember how the subject started and which adjectives are modifying which nouns, you are mentally going through this process of keeping track of what to remember and what to forget, and how to think about what's important as you modify it and get the whole meaning of the end when you get to the end of the sentence. I don't think I had a period in there. That was a very long one, right? Okay, so now I can take these LSTMs, I can look at individual words, one by another. I can stack them. Typically with text, you actually only stack 3 layers. I've seen in more like finance, more than 2 layers will work. This one's 3 for sort of like pedagogical purposes or illustrative purposes only. And by the time you get to the end of the sentence, what you've got is an output vector that if you're trying to train it to do the right task, what it's done is it's learned to do something like capture the semantics of the entire sentence, to encode the relevant meaning of the entire sentence. Word after word after word, paying very close attention to things like grammar and what the entire context of this sentence is as you get to the end. With English especially, it turns out to be very effective if you actually do that both directions. So you read it, you let the algorithm read it front to back, and you let it read back to front, and then you sort of concatenate those together. So what that does, and this is going to be important for a point I'm going to make later. So now you have at each output. You have kind of what the sentence looks like as you read towards the middle, towards each word, right? And so you kind of get a perspective of the sentence pivoting around individual words. But you're also, when you go to the very output, you can look at this like total context vector. And so you have a total context vector, which look at like the full context front to back, the full context back to front, and you can also look at middle context vectors as they meet in the middle. And this has just, the game has been blown wide open. Now we can do so much more. We can do novel text generation. Where you sort of encode the sentence, and then you use that to prime a second neural net, a recurrent neural net that then will kind of unravel that sentence, decode it. And then what it'll do is, you'll prime it with that vector, and then you'll get that output for how to start the sentence, and then that'll feed in, and then so forth, right? And it'll start writing a new sentence. And you can do that, you don't have to do that like English to English, you could do that English to German. And so this is the core of what goes on when you're doing neural machine translation. It's been very effective in improving our ability to do neural machine translation. And so now you're decoding to a mathematical encoding, and then you're encoding to, mathematical to a vectorization of the entire sentence or phrase or whatever it is. And then you're decoding in another language, and you're learning you have to learn the parameters. You can't just decode generically, but you probably can do pre-training. Now, another thing that's been really effective is attention mechanisms. So attention mechanisms are good for things like text summarization. Attention mechanisms, remember I said that you kind of have these vectors all the way along, at every word along the sentence, you kind of have the view of the sentence from the front to back, from back to front, meeting and pivoting around that individual word. So now we can take these vector representations that are the representation of the sentence pivoted around that individual word, and we can build an attention mechanism on there. And there's all sorts of techniques on there. This is something where we put a lot of work in the project that I'm going to be talking about to figure out what's the most important sentence, what's the most important sentence in the paragraph, what's the most important word in the sentence. And actually, I'm getting a little bit ahead of myself. What I've done is I've talked about a generic recipe for taking semantically rich words in order and encoding that into a sentence vector, right? But then you can do that again, and you could take sentences in order that are semantically rich and encode them and as a paragraph vector, or take paragraphs in order and encode them as article vector. This is called hierarchical bidirectional LSTM with attention mechanisms. And so you've done this. If you had the attention mechanisms in there, you've turned your words in order into sentences. You've turned your sentences in order into paragraphs, and your paragraphs in order into articles. And all along the way, you've paid attention to what are the most important words in the sentences, and sentences in the paragraphs, and paragraphs in the article, to whatever task you have at hand, and you backprop through and learned how to pay attention to the right things. And this is exactly what we did. So now we're going to bring it all together. Remember, I started with the goal is not truth detection. The goal is how do you sort between credible information sharing, articles that are focused on that, and articles that are doing emotional manipulation. Under the hypothesis that maybe that does help with fake news, because fake news needs manipulation to humans are and when they're not emotional are incredibly rational, and what we want to do is make room for the reader to judge for themselves in a sober manner whether or not the evidence presented is true, right, or verifies the conclusion, right? So this is what we did. We actually, we have created a beta version of it at fakerfact.org. And there's like a Chrome extension, there's a Firefox extension. We had some students from Galvanize who are working on an iOS app. And what it does is it actually, you can go to a website, and maybe I could just do this, right? So, yeah, so you can go to a website. I already went to FakerFact and downloaded the extension. And then you can actually, let's say you're reading it and you're like, wow, I wonder if this is trying to manipulate me. Sometimes maybe it's New York Times. Not everybody agrees, and sometimes it does. And then it'll give you a score. And actually, this is something that it's not released yet for the public. I have a special account, but remember I said this part is so this part is public. You can use this. This why does Walt think is journalism? That's not there yet. This is dev mode, but it actually will pull out. Remember I said there's these attention mechanisms, so it'll actually pull out which sentences influenced the algorithm. The algorithm we're calling Walt for Walter Cronkite, by the way. That's what it's. In case you're wondering why I'm saying Walt. So which sentences influenced Walt the most in drawing the conclusion that this is journalism? Now with journalism, it's a little bit conceptually, well, shouldn't every sentence be journalistic? And that's true. It's much easier when you're dealing with like with something like satire or something that's sensational or opinionated or agenda driven. It'll actually detect the most ironic sentences in the satire. Yeah, so maybe that's funny, right? So yeah, so it's really, so stay tuned. Hopefully in like a week or so we'll have this for public use for everyone to play around with. Yes. Yeah, so that's important. So some there are some like URL detector, like they're just on like blacklist sites. We didn't do that. Number one, we there's a BS detector. It's just a blacklist checker, and it has a lot of critiques on it. Mostly, this is just a liberal bias, blah 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 blah. And I think there's some that also say it's got conservative bias. So it's both. And we didn't want that, but more importantly, we want every article to be kind of judged on its own merit. So if the Huffington Post writes an article that's journalistic, then we want it to be scored that way. And if it writes one that's not, we want to keep the bar high. Same for, if New York Times lowers the bar and lets some sensationalism in there, which sometimes that does happen, it'll catch that. And so it only looks at the headline text and the body of the text, and occasionally, because I'm a data scientist and not a web scraping professional, some junk HTML that also gets fed in. Hopefully with this you'll see when that happens. It doesn't look at the author. We've thought about doing something where we actually keep a catalog of authors, and they can sort of like Google Scholar, they can post their papers, and then it'll like give an average, sort of like a credit score. I don't know, but I do this nights and weekends, so things move slowly. Yes. That's a very good one. Yeah. So we've scraped millions of articles, and usually we get convergence around 500,000 each. For each class for these articles. So it is a lot of parameters, and it does take quite a bit of training data. What we do is we sort of curate that with reverse bootstrapping process, which actually pulls out the ambiguous ones. If you think about like a URL, different URLs are not going to be, for the most part, 100% of a single type. So you can't, if you just train purely on URLs, not only does that give you the whole bias thing, it also it confuses the algorithm. So we go through a process where you alternate and pull out the ones that are ambiguous with a holdout set, and then you go back and forth. No. We do have some, because bootstrapping is risky, you can let kind of catch a groove in the data and go the wrong way. We do have some hand curated holdout, or like golden data set, to make sure that we can verify things like, by doing this, then when we purify, we actually make the algorithm better on the holdout. Yeah. So this is really what I was focusing on in the beginning. I know it's been a little bit difficult, getting settled. We're not detecting facts. We're not detecting, a fact is something, a necessary condition for being a fact is that it's true. And that's hard to do. It's hard to check facts, to check truth, to have an algorithmic truth detector. What we are doing is actually checking for manipulation. And while you're right, a big merit of an article, especially a news article, is if it's talking about the truth and it's well cited. Another merit of a news article is if it's trying to manipulate the audience. This goes back to this phenomenon that if an article is trying to manipulate the audience with anything other than the facts. So a real journalism, and we have some definitions that we're going to post on Fake or Fact imminently. The definition is something like, it does not try to convince the reader by any means other than presenting the evidence for the reader to come to their own conclusion.
So how about like borrowing an article, let's say it'll be from a credit news source, like say a Washington Post opinion, or would it break down, would it break?
So Washington Post op-eds, in fact, any op-eds from any news organization does not count as journalism in our training data. That gets classified as opinion because the op stands for opinion, right? And that doesn't mean necessarily that it's bad. In fact, none of these scores necessarily are going to be. So let's check. Put Huffington Post and Breitbart in incognito modes. So this article from Breitbart ranks high in opinion, right? Now that doesn't necessarily mean you shouldn't read it. Maybe you like opinion pieces. Maybe that's fun for you. Maybe that's self-soothing. It's just like when you eat ice cream. It's not like broccoli, right? But you eat it anyway. And I do this too. Sometimes I read opinion pieces and I enjoy that. But having that up front, that this is the mode of engagement, of news engagement or entertainment that you're participating in, that's hopefully going to be helpful. And hopefully something that you can, we have some share buttons there, although we haven't really, we got one guy that does all the web front end, back end, everything, and then 6 data scientists that do the algorithms. So, but hopefully that's the sort of thing that you can actually mark. Like if you're reading a Facebook article and someone posts it, you can say, well, it says this is opinion, so, yes. With the reverse bootstrapping. So we started with the URL level, but then we curated. So Breitbart's a good example, right? Breitbart gets a lot of flack, and a lot of them will get scored, opinion or sensational. But I would this might be controversial. I would say that some of the articles are, if you sort of just take the text, they would be indistinguishable from journalism, and we would be remiss to label it just because it's found on a certain site a certain way, or even worse, we'd make less effective if we trained. And actually, Breitbart is such a mix that we don't train. We don't even start the curated seed set. None of the Breitbart articles are in there, or Huffington Post for that matter. Yeah.
Question, Mike?
Yes.
Following up on the same thing, so you label the data based on where it is coming from, or?
So we seed the reverse bootstrapping set that way, but we don't we don't label it just blankly on URLs. There's not. Okay, yeah. So there is 100 words issue that. So if it's probably half the time there actually are more than 100 words. I'm just not so good at scraping, but you can paste in the text too if that happens. So let's check some. See. Crap. So you just paste it in. Yeah, and so So she too gets she Huffington Post. It's not Ariana. Gets opinion pretty frequently. Yes.
That kind of leads into like the next logical step. Is do you think people are going to start using this to categorize authors and categorize news sources based on the categorization?
That's a potential use case. It's for large scale feeds, right? So like Microsoft News. I'd love to see when it's not perfected yet. I'd love to see it used in social media as something that fake news travels faster than real news. And so having a little bit of friction there when something is posted, but Walt, for good reasons, because Walt cites its reasons now or will in a couple weeks when we release this feature, shows why this is maybe not pure journalism, right? Yeah.
So, especially after you started using more information, how much plus do you think will get in someone's mind to not make better journalism, just making better?
Making more insidious fake news, SEO hacking their fakeness, and so I get asked that question all the time, and it's a great question. What if the bad guys, the Russians are like they start using faker fact to get to make their really boring fake news, and then Walt can't tell, isn't that bad? And my attitude is that's kind of the dream, right? If all the Russians have going for them, or no, maybe it's Russian, if all the fake news authors have going for them is that they're presenting things that sound like facts but are not true, but in a way that doesn't manipulate our emotional manipulate us emotionally and depress our cognitive engagement, so that we can draw conclusions for ourselves. Does the evidence support the conclusion? That's what we want, right?
In terms of like retraining, how do you roll over time as people adapt?
Yeah, so certainly we release new models and try new architectures. I kind of presented the basic building blocks, but there's a lot of things like convolutional layers and compression and as you're going through this hierarchical layer, how much do you manage the dense nets that tie it all together? In particular, so something equivalent, and we'll probably publish on this hopefully within the next few months. Something equivalent to like max pooling for the attention actually works the best for like how it actually pulls out these sentences. So all of these things we're trying and iterating on on almost a daily basis. And so we're retraining and refreshing the data as well. So there's a lot of fake news public data sets. A lot of them and now seem old. You could tell depending on how they refer to Hillary Clinton versus Donald Trump from 2016. You could detect it with just TF IDF. And so biasing your training data set based on the time from which it was sampled is also has a big impact. Speaking of time, someone last night someone asked a question about Kennedy. They're like, well, come on, sometimes there's just really shocking and sensational news. What if you check the New York Times and what they wrote about the Kennedy assassination? So I actually checked that out. There it is. So this is evidently there's like an archive site, and it has the actual thing, the actual text down here from the Kennedy assassination. It was a live demo last night. Now I know what the answer is, and it scores journalism, right? So maybe this is a symptom of the fact that they were even more sober in the New York Times in 1963. But also it is possible to have remarkable news written in a journalistic style. Yes. It's a good question. One of the fun things about now being able to see the attention mechanism is you can sort of make your unscientific speculations on what actually influenced the algorithm. We do know what works and what doesn't work, right? Adding attention mechanism will improve F1 score by like about 5 to 6%. Doing things with compression will adding things like title. Compressions in different ways will give you a couple points here and there. Most of these, so we can actually view details. So journalism. So the one that's live right now has precision 98%, recall 96%. Evidently, we have 2 in journalism. So this one's more balanced. We do tend to like to look at the ones that are we want to bias our algorithms that are live towards ones that penalize false positives over false negatives. So precision over recall, just to give the author the benefit of the doubt. Wiki sort of fish in the barrel, right? That's like 99.8%. So a couple in 1,000 will get wrong, but that's pretty easy. Opinion 97, but 83, right? So this one we wanted to keep the precision really high, so we actually let it drop to the 80s for recall, which is okay. What else we have? Satire. So satire, barely 90% recall, but 98 precision. Sensational again. You let it drop all the way to 75 for recall at the cost, or as a cost for getting 97 in precision. Agenda-driven. So we have several agenda-driven models, and we're actually ensembling these, but they're all, roughly, like 90, 91, 93, 90.9, 93. Yeah, and it's interesting. We just started doing these features, so I can't speculate too much. So for when it's like an agenda-driven one, these seem like pretty sober. I don't know if that's legible. Like pretty sober sentences, but of course it labeled it as a 0. So this is something that needs to be investigated more. But it seems like actually a low score from agenda that the scores that the sentences that it's paying attention to are actually going to be more journalistic, which is I think you might speculate that, but we haven't investigated it yet. That's something that we're starting to see. Yeah. Oh. Sorry. Go ahead, and then you. Yeah. Yeah.
Have you already tried it on UK data, for example?
Yeah, so I was in London a couple of weeks ago, and I used all London websites. It's pretty much the same sort of demos.
Other languages?
Other languages, no, because it's trained on English. So it can only, the embeddings are only English embeddings to mathematical representations of those English words, vector embeddings. For other languages, the only hard part, which is not a trivial hard part, is creating data sets to train on in those languages.
You said that max pooling was the best way to infer.
Yeah. It's not exactly max pooling, but it's somewhat similar to that. So it's sort of like a max vector, and we use that and then compare with a full. So if you think about like with attention mechanisms, you could do dot products. You could do something that's a little bit more sophisticated, where you actually learn the entire parameters or the entire matrix, and then you do this. It's sort of like an affine comparison of them. If you learn all of those parameters and you compare with what's like a max vector versus the individual ones, that's that is with there's a couple other details, but that's what's at the core of what generates these sentences. Oh, so this you mean as in like, so we use GCP. We got this is thank you from the sponsors at GCP who it's done in PyTorch. Yeah. So.
So in the optical light, there is like both CNN, DP, AWM, Max loss.
Yeah, you can kind of reverse engineer. This is not, trade secrets. So these are just for us. We have some naming conventions, so we can keep track of like what are the most relevant features that we're checking in our hypotheses. So we create dozens of these a week, and so sometimes it's hard to remember like which one was which from a hash. And sometimes we have to actually change our naming convention because it's pretty clear. For instance, for this one, so max, for instance, is this max pooling thing, right? It's pretty clear that that's the dominant one whenever we do our hypotheses, and so we probably don't need it anymore. Right? Yes.
Does it training algorithm, does the algorithm train itself when there's more and more uses?
Does it train its?
So the more it's being used, the more it's being trained, things like that, or do you control the training data?
Oh, you mean like getting feedback? So there is, if you sign in, you can like give your own like feedback on if we did well. So you can say, oh yeah, I do think this is journalism, right? And then that'll get recorded. We have to be really careful what we do with this data, and problem not solved yet. There's surprisingly little sort of like prior art on how to rate the raters and how to make sure that if you have no information on them. And so we're working with some equivalent, like there are some abstractions or generalizations of like PCA for tensors that we can do. There's actually several different ways you can do PCA because it reduces to a single algorithm PCA in 2 dimensions, but there's several ways. And then what that can do is actually give us indications of stratification if you have people that rate enough things. And then in principle, you can stratify the raters and then make sure that you're not biasing too much, or actually you can learn and correct for those biases per strata. But I think that answers your question. Like, so is there? No, that would, this done wrong would end up being a thermometer of the user base, right? Which is probably not going to be helpful. Yeah. Is this a workshop? I told them I maybe. So we don't have code. I'm sorry. Is everybody waiting for us to do code? Shucks. That's why they gave us such a small room, right? No, this is just a talk. But we can chit chat about algorithms all you want. Yeah. So, sorry, I'm having trouble hearing everything.
When you incorporate things like a headline or something, do you encode that differently from the normal attention convention? And if so, like, where is the hierarchy of word sentence?
Yeah. Yeah, so what we found, and like I say, we try lots of different things. What we found works the best for headlines in particular. We have these portholes. So we have the hierarchical mechanism that's going through the body of the text and rolling it all up. But headlines are much smaller, right? You also don't necessarily need to encode them in the same way. So some might work better with glove. Some might work better with glove and a convolutional layer on top. Some might work better with just straight old word vectors. So we measure all of that, and we've been tweaking with that as well. With the headlines, that's better if you actually do it as a porthole and you combine that and concatenate it at a certain level in the hierarchy, rather than doing like feeding it on the bottom or maybe having multiple ones at the very top.
Do you find that it works better like closer to the end of the full network?
Yeah. Headlines work better when you move them up closer to the top. So is this? Maybe I got it totally wrong. Are we out of time? Is it, no? How much time do we have? Till 1 p.m. Seriously? This is a 2-hour and 15-minute workshop? Yeah. From 11 to 1. I do have some like how to build a basic classifier notebooks. If you really want, we can. I'm losing the audience. You know. Yes. Yeah. Yeah. So how much time do I have? Plenty. All right. Well, let's. Yeah, I can. Let's see. Let's see here. Yeah, please. And I apologize for not making this a workshop. No one told me. Yeah, so that's done with these. That's done with these attention mechanisms. So remember before I was talking about there's something like max pooling. So the mechanism for actually taking each of these, at each of the words, you have this kind of bidirectional representation of the sentence from the pivot around that word. And so that's an encoding vector of the sentence, right? Now you want to figure out, for that sentence, you want to figure out, well, which ones are the most important ones. And what we found is the best is you have this max vector, and then you have a matrix. So let's say you have 300 by 300. It's a 300 by 300 matrix. You take the inner product with you're sandwiching the matrix in the middle. So that's going to be 90,000 parameters that you're learning in order to do that. Yeah. Yes. Of all, across those, that individual sentence or paragraph or whatever it is, right? Or sequence of paragraphs. Yeah. Yeah. Yes.
Question on a hypothesis. You are using this hypothesis to find fake news. I'm thinking if it can be used to identify phishing emails when emails come in.
Yeah.
Do you have any experience in that area?
No, we haven't applied it to that. There's a very high likelihood that there's like a lot of human engineering that goes involved with that, right? And so I would suspect because it's because spam works on the same principle, that we'd be able to detect signal there. This is a pretty generic infrastructure, right? Obviously, some of the bits and pieces would need to change. I would suspect it would have an effect, though, at least with some effect, right?
So if I think on the same line, emotional content, we're trying to understand the emotional content of the email, which will probably reduce the cognitive action, and that will make the person think on something that they're not supposed to think. Mm-hmm. How would you suggest going about capturing the emotional context out of
the emotional context of the
email text? In this case, like whatever you have used, you're trying to understand the emotional portion.
Yeah.
More in terms of fake news. And that's why I was more interested in how you're labeling the data. As you have mentioned, if you can share a little more.
Oh, so where do the labels come from? Yeah, so the labels come from, you start with the URL level, and then what we'll do is we'll actually let the algorithm go back and forth. So we hold out, let's say, half of it. We curate through, we train on the first half, and so this is like sort of like dirty data curator. Then that curator will actually label the second half and will pull out the ones that are ambiguous cases, right? So it's never seen that data set before. It's pulling them out. Now you can retrain, and you can actually cycle through there. There's a process of reverse bootstrapping, right? So it's like bootstrapping, but you're starting with dirty labels.
You're iteratively enriching the label quality.
Yeah, exactly. And then on a holdout data set, like a golden data set, it actually performs much better. Yeah. Yeah. sorry.
So let's say you're classifying for one thing, and then you, as you said, you like train on the first time, but then on the second time you see something that is different than the first time. Are you saying that you're kind of like coming up with an 11 category, or not? Is it like some sort of what do we call like zero shot learning that you?
No, it's actually retraining fresh. So it's retraining fresh on iteratively curated, self-curated. So it's curated by the last iteration of the model. And when I say last iteration of the model, I don't mean that it's retraining or that it's updating the model. It's actually training that model fresh on the new, more purified, lower entropy data set.
But the very first round, you have to tell it what those categories are.
Yes. Yeah, you do. And that's done with pretty, we try to have a pretty high bar there, right? So even Breitbart doesn't make it. Yeah. So I feel like we should probably just close a little early. I apologize for not making this a tutorial. I told them I wanted a lecture. I'm happy to just stick around for an hour and chit chat.